So welcome to the webinar.
So I'll give you the feature for the modeling functionality. So the first functionality SDS offer is 3D modeling inputs. Then SDS has an automated connection. You can import reference models for expediting your work. You can also export all the market popular MRP and CNC integration reports. You can also have your crane placement for coordination purpose. You with the automated connection design, SDS also generate a design and engineering calculation report which you can submit to your structural engineer. SDS offers a toolbox functionality, so it basically streamline your workflow and it automates the repetitive task. So these are basically plugins which you can use, for repetitive task and to export out many reports which other software may need. Okay, so then you have your load and delivery planning, which is for your logistic management. So okay, so now we'll jump on to the SDS2 functionalities. So what SDS offers? What are the key features? So the first and foremost key feature of SDS is connection design. SDS gives you a fabrication intelligent connections. SDS has an auto piece marking feature. So we are going to cover all these in coming slides. Then SDS provides a drafting module and also have a free viewer. SDS provides hyperlink drawings. It has a high quality of export drawings. It has a filtration option called as status display. It has integration and partnership with all the market popular softwares. SDS has a live user modeling feature. It can handle complex geometry and it has a cloud collaboration platform called as BIM Plus. So let's start. So Purna, I hope my screen is visible and am I audible clear?
Yeah, yeah, perfect.
Okay, okay, fine. So m- all the detailers, they might think what is the use of a connection design in a in a detailing software. So if you see these two silos, you can understand since there is a automated connection in SDS, so the user input is very less. You can see here you just have to give a few information like your fabrication design standard loads and you have to make a 3D model and SDS fabricate SDS intelligently, does all the analysis and gives you auto applied connection types, all the material bolt size it analyzes. It also gives you a design calculation. Now what will happen since the user input is less, you will have less time in executing a project and also there will be less human errors. So by this PPT, I just want to show you like, nowadays all the detail in like the connection design responsibilities landed onto a detailer. So if you see this yellow arrow, so if you have a connection design feature in your detailing software, so this coordination part will get streamlined. You do not have to again and again go to a designer or to fabricator for asking for what type of connection you have to do. So since in SDS there is a standard AISC compliant and IS compliant connection design feature is there. So you can simply just read your design drawings. You can make a stick model. You can auto apply the connections. You can ask your fabricator what preference, connection preference he wants. And based on that, you can develop a connection onto your model. You can generate design calculation. You can directly submit to your structural engineer. He will since it is code compliant, there are very less chances of having any changes. Your designer might give some changes which you can later apply onto your detailing software, but meanwhile you can start doing your drafting work and your shop drawing and field drawing creation. And when you get the comments from the structural engineer, there might be a 20% of rework, but it will basically expedite your work. So I just want to show you. So in the Indian feature, we have all the latest IS code compliant. That is IS 800, IS 4923, IS 808, IS 1173, IS 1161, IS 1239, and we also have Tata and Jindal sections. So let's start with how SDS do a connection design. So whenever SDS has you do a, a stick model, so it is a fabrication intelligent machine. So it does not just stick a connection from a library, but it basically analyze what is the project specification, what is your fabricator preference, what is your load, what is the region where you are executing the project, your steel section sizes, availability, and your framing situation, and then it develops a connection. And whatever connection which are developed from SDS, they are erectable, constructible. You have the complete control on what type of connection you want, so they are optimized. It checks the complete node, and you can apply the connection to the complete structure. So we'll go one by one with all the points. So I just want to show you one video of how the connection design is done in SDS. So if you see here, as I add the beam, automatically the connections are being generated. Okay. Now for the generated connection, I can easily take out the design calculation. Okay. So this is the design calculation report, which is based on the code compliance. So you have the complete design code. You can anytime you can change the connection type as required. You can change the number of bolt as per your fabrication preference, or anything, any thickness, anything as per your fabricator or your designer. Okay. You can change the loads, and SDS will recalculate the complete connection, and it will revise the connection. Also, if suppose you do any changes, this is the fabrication intelligence part. So since the SC bolts are applied, a special gun is required, so SDS has changed the connection to extended tap connection. So what is a constructive and erectable connection? So whenever SDS design a connection, it checks the space validation of steel. It checks the bolt clashing avoidance. It checks the material availability. It checks the material thinning. It also checks the galvanization tank and the truck bed size, and it eliminates or reduces the field and shop errors. So if you see these images, you can see the image number one. There, SDS has provided a cut and at the top of the flange, since the column depth and the beam top flange is almost of the same depth. SDS has provided at the cut at the bottom of the beam in image number two to have a ease of drop down connection. In image number 3 and 4, SDS checks the space validation. It develops a shared connection as per OSHA, a shared clip angle connection as per OSHA. And since there are stiffness, SDS has generated a extended shear tap connection for ease of drop down connection, and these connections are system generated. These are not sticked from copied from any library, or not a manual connection. So this is another video to showcase how the constructible connection works. So as you add a beam, what happens? You can see the brace is auto adjusted, and also SDS has provided cuts on the top and the bottom flange of the beam. Now, if I try to rotate the column by 90°, you can see the cuts are adjusted on the edges in beam. And this is completely system generated. There is no human interface. I can change the connection type, okay, and and the bolt type. So here also I'm changing the bolt type to a SC connection, and I'm changing the bolt diameter. For this type of connection, a special gun is required. So SDS has developed a extended tap connection for ease of bolt installation. So these kind of fabrication intelligence is there in SDS. Then what is a complete node? So like when if you are doing any connection on one end, for example, you are doing a connection for this beam, SDS will also analyze the impact on the other members which are connecting on the other faces. So, if suppose you are doing a moment connection and stiffeners are added, SDS will fabricate, it will, do the fabrication intelligence. It will provide you of options, what possible connections can be done, or it will, change the connection and gives you updated connection cals. Complete optimization means whenever a connection is developed, SDS will uh, give you a calculation, but because of material and time saving, if your fabricator opts for any other connection design or any other connection option, you can always change as and then required, and SDS will give you a revised calculation for that. So auto piece marking is a feature, you know, uh, which expedites your work. So how does it work is basically if you're adding any identical beams, for example, you have added 10 identical beams, SDS will club all those beams and give one system piece mark. So if you see in this image, there is B underscore 270. So these two beams are identical. SDS has clubbed the mark. Now how it will help you. So for example, if I go and if I change the connection type or if I add a hole, it will ask me whether you want to imply the same changes in other 10 beams or other identical members. So if I press yes, so it will apply those connection with one single go. It's just a small case of 10 beams, but let's say there is a big warehouse where you have identical 100 or 200 beams. There it will expedite your work and it will streamline your work, and there are very less chances of having human error or missing. You will miss anything to apply on any identical member. Then SDS also have a drafting provision, which other competitor softwares do not offer. And SDS has a free viewer which can, uh, you know, uh, save a huge cost on your project ROI. So SDS has a live user modeling. What does this mean is, suppose person A is working on his system and person B is working on his system. So if person A is adding a beam, the person B can see it in a real-time basis, and you will not have any last moment surprises. How generally the other detailing software work is, basically you have to add a model, then when you save it, then only the other person can see it. It gets saved into their cloud server, but that is not the case with SDS. For this, we have also conducted a survey where 85% of the participants has stated that this feature has made them work divide their work in a more efficient way, and 54% of the user have got an opportunity to work efficiently remotely. So SDS has one more exceptionally good feature, that is handling a hip and valley, or a complex geometry or a complex framing, and SDS can also automate those connections. So SDS has a direct plugin for adding your secondary steel or your complex members, like your stair, your handrails, ladders, post stops, girts, clevis and turnbuckle, and miscellaneous assemblies. So I just have a video how easy it is to add a stair in SDS. So if you see here, so what I did is basically I've imported the 2D drawing into the model, and I am just picking the nosing points, and SDS will give me an entire stair tower within seconds. So this is my entire stair tower. For adding the railings, I just have to, select my quick handrail adding tool or plugin, and the handles will be applied on the same geometry to the entire tower. Doing any modifications or changes is also very easy. This is just a skeleton. You can optimize the stair as and then required. You can change the flight, your material type, your slope, or your return, anything you want. You can do that with one single click. SDS also have partnership and integration with most of the market popular software. So you can see SDS has integration with Autodesk, Revit, CoreBrace, Dura, Fuse, Hexagon, Magnus, MITech, Risa is our own product. Then Simpson and Voice to CAD. Okay. In automated robotic machines, SDS has direct integration with AGT Robotics, Bentech, Control Automation, Diota, FISIP, EMI, HGG, Lightning Rail, Lincoln Electric, Padagus, PEP, Shop Data Systems, Sigma Nest, Vernon and Woodman, and Zeeman Export, that is a welding machine. SDS also provides you all the reports which are generally required in a fabrication process. That is ABM report, material takeoff reports, your cut list, your shop bolt and field bolt list summaries, your bill of material reports, and also you can customize any report. So if you need any specific report in a specific manner, you can just define your parameters, what you want to include in that report, and SDS will give you that report. SDS can also give you import and export all the 3D formats which are generally available in the market. That is CIS2 .stp file, IFC file, both 2 by 3 and 4 also IFC4. DGN, DWG, IGES, STP, SDNF, XML, E57, that is point cloud files, and XML Revit, and .ntl for S3D. Also, SDS can import and export 2D formats, that is DWG, DXF, DXB, DGN, PDF. So SDS, other features what SDS offers is a BIM Plus. So SDS has a cloud collaboration platform where you can directly access it through portal.bimplus.net. So you can upload your project here, and if you want to share it with your reviewer, you can share it. It has some basic markup tools. You can also include your drawings and connection calculation in this, and that model can be reviewed by your designer or structural engineer. He can mark his comment. He can uh, take the error takeoff list. He can take material takeoff. He can use out of it. He can review the model, and uh, if you are on the same platform, you can have a collaboration in a real-time basis. SDS also offers the toolbox option. This is generally available for any member who is on current subscription. So this tool will help you to streamline your work, automated repetitive tasks, and control your productivity. It is designed for integrating seamless with SDS2, and these are small plugins which you can use. So it has plugins for your Autodesk and most of the market files or any special type of connections, and you can directly integrate it with your SDS, and you can generate the desired output files. SDS also give you a cost estimator machine. So in your entire model, you can feed the material cost of your weld, your holes, and your member fabrication cost. And with one single click, it can give you an Excel report of your project. So you can see here what type of materials and what is the grade and what is my quantity it has taken from the model itself, and it has given me a total cost in an Excel format, which I can submit to my fabricator. It can also help you in estimation process. So SDS, along with modeling, SDS provides a ST modeling also, that is plugged in. That's a standard format which is in the model only, in your license only. So you can just simply make a stick model, and you can take out your quantity takeoff. Along with that, you can use this cost estimator, and you can send it to your fabricator. So there will be a high chances of winning the bid. SDS has a tool for erectors also. So what you can do there, there at at job site, there might be tight schedule, and you have to send some particular sequence in advance. So with this tool, what you can do, you can set your erection order. So for example, if you have sequence 1 and sequence 2 and sequence 3, and the fabricator wants sequence 2 first, so you can set what steel supposed to be erected first and what should come last. So you can set the numbers, and you can take out the Excel report which you can submit to your erector for expediting his work and coordination purpose. SDs also have a logistic planning tool. Load planning is not the load on a beam. It is generally how you are going to load the steel on a truck. So in this, you define your truck bed, what is your offset, and based on that, you can load the steel in the most optimized way, you know, and it can help your fabricator to uh, do his logistic task in a efficient way. These are some classic examples which are done in SDS. So the first is the Jocelyn Art Museum. It is in Omaha, Nebraska, and this is a non-linear building. You can see these kind of complex connections are there. It has a rolled stair, curved stair, and the curved floor geometry and roof framing is also cantilevered, and SDS has executed this project. This is another project that is a community independent school. This is also having complex road stairs and complex geometry, which was done successfully in SDS. This is another project which is of Gillette Stadium edition. It was done by Moltec, and it is a lighthouse which is 22-story and 360 degree observation deck. So now I'll start with the SDS2 demonstration. It will hardly take 30 minutes. So I will just give you a brief introduction. What is the tool? What is the capability? And how the connection design works. This is the main home screen of SDS. This will basically tell you what license entitlement you have. Currently, I'm using Ultimate. Then this will let you know about the versions. So currently, I'm working in 2025 version, and I am working on a North American module. This is the current project what you're using. You can pin a project so it will can be populated into this field. You have your recent projects, any new recent project which you're working on. This is your fabricator file name, and this is the repository where your jobs are saved. You can also map your server and keep your all the jobs on a common drive. Then the horizontal field is all for the learning content, and this is the main tools for current live project which you can use. SDS have this options for modeling, opening a modeling window, and this is for opening a drafting window. So in SDS, if you have a instead of Ultimate, if you have a modeling and a drafting license, so there also you will have both of the tools. But for example, if you're working in a modeling tool, all the modeling related features will be activated. Drafting will work as a viewer. You can view the drawings. Okay, you can navigate through. You can open a report, connection calculation, or any kind of report, but you cannot edit anything. Similarly, if you have a drafting window, modeling will work as a viewer. You can view the model, you can navigate through, you can add the notes, but you can only use the full capabilities of the drafting license. Then we have, if we come on to the horizontal plan, so this is the learning window where you have all your new features, small videos are there. Then you have your getting started videos. You have online training which is free. You can learn more about SDS. It's a self-paced training, and you can also check the release notes, the latest SDS2 version, what all things have been updated. Okay. Then this is the support area where you can contact us through this direct link. You can send us an email or over the call. Then we have the technical support. So if you go here, we have small chunk of FAQs or toolbox items. Information is given. It's a self-learning content. You can go here and you can take the technical support. Then this is the download center from where you can download the SDS2 software. If you want to send any model to us for review, you can upload the model. Then this is add-on where it's just the information what all we have. So toolbox is one thing what I want to have you a look at. So toolbox are separate plugins which these are free of cost. If you are on the current maintenance, you can use this. You can simply check. You can download this. You can go to any view more option. You can see this all these versions. It is available. You can, for example, I'm working on 2025. I can download this, and as I play this, it will get integrated into my main window, main license, and then you can use this. So there are a lot of partnership and integration which SDS have. So all those tools are there. For example, your BIM upload, this is a cloud collaboration platform. We have all the updated as AICCS file. We have preliminary load planning, erector order, then Pentec export you can take, HGG pipe cutting machines export you can take directly. Autodesk Revit integration we have. Resize our own product. Then we have direct tools for adding a leveling plate or a no paint surface or a beam bearing plate. The shrunken connections is there. MITech, you can directly generate a connection. So a lot of tools are there. You can go through these. Then we have an explore option where you can read our recent blogs and about any webinar upcoming or SDS2 summit, any events are there. And this is the community. It's basically all the posts what we are doing on social medias and platforms. Then about is basically what license I have. Okay. Then coming to the vertical points, now we have started with the technical part. So first is home, where you have your home screen. Then you have your analytics, where you can refresh and you can check what all members are there in the project. So it will give you a presentation in form of a this graphical presentation, where you can have what are the member counts, what is the tonnage, and you can send a report to your fabricator. You can see on sheet these many members are there. Then this is the project setting. So SDS, since it have a connection design, it have a dedicated area where you can feed a lot of information, and your projects will be your fabricator preferred setting, what preferred connection you have, what is the load, okay, what is the minimum design calculation you want. So a lot of parameters you can feed. So this is the fabricator parameter. Fabricator is basically, if suppose you're working with one fabricator XYZ, you can feed all the fabricator related information here. So for example, the what standard connection he is looking for, if he is using a clip angle connection generally, so what is the gauge he is using, and all the those related things. Then the piece marking. So for example, if the fabricator is having a dedicated piece marking, you can use it from here. Okay, so for example, you have a standard plate, you can write the piece mark. If he has a dedicated piece marking system, you can write here what is the length and width and other properties to associated with that piece mark. So you can populate that field, and whenever SD is designing a connection, it will always choose the data from this and it will allocate the piece mark as per fabricator preference. Similarly, you have option for your sheet and report. So what kind of sheet layout fabricator wants and report he wants, you can set it here. Then detailing option is there, so you can set a lot of other parameters, like what is the dimension, how the clients want the dimension, how the drawing should present, what is the line thickness, and weight, how the drawing basically the font size should look, what is the line thickness, and all those kind of information. This is general presentation, bold detailing settings. A lot of settings are there. Okay, so like remember detailing settings. So if I go into here, so if I have a beam, so what are preferred style, and also I just go to help windows to make you explain in a better way. So for example, how my view should come, whether it's a cross section or a bird eye view. Then what all dimensions I want, okay, whether I want this dimension, all these. The next thing is here, what type of bolts you want, what type is the material grade, what is the surface finish. Again, modeling, you can see your job north, what is the terrain, okay, any member revisions, and those kind of predefined colors is basically what you, how you want to see the color of that particular member in the model. So similarly, there are a lot of information here also. Then you have an option for report. So you can generate a report here. Okay, so you can generate a ABM report or a correction design report, or you can also have the system reports like your bill of material reports. Then you have your field bolt, shop bolt, material assembly report. You know, then you have your sheet loading report. Then you have your you have your revision chart report. So all those reports you can run. Then there is an import and export option. So import, you can see SDS has an auto detection feature. So you just have to import. If you want to import a model, you just select the model. SDS will automatically analyze the format and it will import it. Project transfer is basically if you want to send a native file of SDS to any customer. Okay, so the native file of SDS is .jfd. You can send it to any fabricator. Okay, so for that, this option is used. Similarly, you have an export option where you can export model for floor planning, new models to Revit. Okay, PowerFab, FabTrol, KSS, EJ, a lot of files you can send. Just okay, then you can have you send a CNC file. You can submit PDF drawings. You can prepare a transmittal. Okay, you can also export 2D drawings and CAD files. Then, okay, so this, and here also you have a project transfer option. So project transfer option is somewhat like this. So you can tag the project. This is for exporting, and you can unpack the project. So if suppose to some customer has sent you a native file or a seed file, you can directly unpack it from here. Then you have a utility option. This is basically for uh, your hardware settings and all. So this is shapes and properties. What all shapes and properties SDS have. You can also do one thing. You can add your own shapes if required. So for example, we have wide flange channels, angles, WB pipes, HSS. We also have welded plate section. We have welded box section. So you just have to feed these values in the below table, and you can have your own profile which you can use in your job. Then joist, we have different fabricators, joist fabricators which are aligned with us, like your Kenam and Wallcraft. So you can choose what fabricator you have. Okay, other than that, you can add CM steel also, your Z-shaped steel, then your S shapes, your rounding bar, your clevis turnbuckle, and these are cruciform shapes. So this is WF and WT, WF plate, plate WT, and plate all built out to section, which you can use for your project. Other than that, sorry, you have your user and site option. So basically this will govern how you want your hardware to look like. So it is opening now. So here how you want your presentation to be, how many mouse clicks you want, okay, and modeling, how it is your background color, how you want it. Those kind of settings are there, okay. And last is the licensing part where you can go to change edition. Okay, so I have to close it, but generally you can see what are license type you have, and you can navigate through those licenses here. Now moving to modeling. Let's open. So this is the main modeling interface of SDS. This is the modeling interface. This is the home screen. So let's me drive through all the options available. So first is the layout option where you can navigate through different views, or you can save any view, and you can add new views through this option. This is for adding grid lines, adding curved grid lines. This is for going to any plan views. So if I go here and if I add a plan view elevation, it will take me to that particular elevation. This tick, if I remove, it will give me a full complete depth, or I can control my depth check. This is for elevation view. Okay, this is for undo view. This is for depth view again. This is snap to surface. If I select this and if I go to any surface, it will snap to that particular surface. I can use it to create a view or review any particular view or member. Then you have add a construction line option. I can erase a construction line, add a circular construction line. This option is for adding members. So I can add the commonly used members like beam, column, vertical brace, horizontal brace, joist. Also, I can add anchor rod, stair, ladder, handrail, post-stop girds, purlins, and hoppers. Also, I have quick command to add any stair, what I've shown in the video. Then you have option for adding any handrail to structure or adding any flat handrail. Then we have option embed option where for you can add embed clip angle or embed blade. You can add concrete, okay, custom place beam columns and other concrete elements. You can add a slab and a footing. You can add wall systems. Okay, you can add assemblies. You can undelete a member. Then material option is there, which is used for adding any submetal assemblies like your plates, rods, your clevis turnbuckle, any grating or decking. Okay. Then your reference material. This is for plugin option, so you can add any extra plugin using these components. So you can add a safety holes, you can add safety tabs, erection tabs. You can add reinforcement at the bottom of the column and beam. Any web penetration, you can add stiffness. Okay, you can add any slab thicknesses. Okay, concrete openings you can add. Then you can add a cap plate or shim plates or any shear keys at the bottom of the column. Then this is for adding port stops. This is for adding a individual hole, okay, or a bolt, stud or welds to a steel. Then this is the drawing option. It is only available if you have a complete license or a drafting license. It is not valid for a modeling license. Since I am having a complete ultimate license, that's why it is active. So using this option, you can place a field drawing, you can generate a action view, you can detail a member, detail a submetal, detail a assembly, you can sheet load the members, and this is the tool for measurement. Another reason, this is another tool option where you can generate a 3D RFI. It's like you can create a PDF which is having a 3D model which you can submit to your customer. This is for dimension and ruler. This is for adding any reference model or point cloud data. This is for adding any 2D reference drawings. Okay. Then this is for updating a vertical snap to surface to a vertical brace. Then this is for your parametric. This is for selection attributes, and this is for crane placement. Then you have a display option where you can choose if you want to see a section size. For example, if I press OK, so now when I see my model, I can see my section sizes of all the beam. So there are other parameters also like ABM IDs or your camber annotations or moment symbols or those things you can use for your review purpose. Okay, I just remove this. I just press OK. Now you have your selection filter option where you can isolate any beam or any member on the these attributes. You have a you can isolate through the sequence zone or revision or whether it is on hold or existing member, to your detailing and processing status, your approval and modeling status, fabrication status, shipping status, member status. So for example, if any member is galvanized, I want that to look into cyan color. If I press OK, so you can see my handles are in cyan color, so these are galvanized. Okay, SDS has also a good option where whenever it adds a handrail, it also adds the vent hole and draining holes in these steels. Okay, it also provides the inside cut in this post, so the galvanized can be done in a proper way. So okay, if I don't want to this selection filter, I can simply remove the stick and the model will go back to its original position. This is for solid, turning any element to solid, opaque, transparent. Okay, turning any connection to solid, opaque and transparent. Okay, this is for the navigation view, so I can split my window into two and I can review the model simultaneously. using both the windows, the import and export option, which I have shown you at the home screen. And this is the same option, report, which we have in the home screen, where you can import and export any report, any APM connection, bill of material, fleet bolt, shop bolt report. Then this is the toolbox option, which I want to show you. So if you go on SDS site, and if you go into resources, you have a toolbox option. So these are free plugins which you can use if you are on a current maintenance or you have a subscription license, and you can directly download and install it, and it will directly get attached with your main license under toolbox options, so you can use it. There are a lot of tools like adding a bend plate, cost estimator, or erection order, or you can send a SAF file, or a stromis, or shrunken connection, bar fab. So all those things you can do using these tools. So now we'll see how to add a members. So I'll simply go on to the tools. The best option, you can import a field drawing in SDS, and I'll just split this screen to show you how the members are being added here. So I'll just go to member and select a column. The column is W14 by 74. Since I have added the drawing here, I do not have to again and again go on to my erection drawing to review. So these are the columns which I'm adding. You can see on the real line basis, the columns are being added. So now if I have to edit anything, okay, so I'll just press SA, select these columns, okay, or I'll just simply select one and I edit it. Okay, so I'll edit the elevation, 36 times 0. And as I press OK, SDS will prompt me, due to the auto piece marking option, that 3 quantities of this column are available. Do you want to have the changes in all the columns? I'll say yes. And you can see all the columns are updated. I'll keep adding the other columns. Now I will rotate the column by 90° and I'll add the other bunch of columns. So escape, and I just simply, so now I will add the base plate. So for base plate, you can select all the columns and you can right click and you can edit. So instead of auto connection, I will go to user defined connection and I will change my base plate to BP1. Okay, and I'll press OK. So you can see all base plates are added here. Now for adding anchor bolts also, you just simply have to go to anchor rod tool. You can choose whether you want to add it into a member, material, or hole. I'll just select member and I just right click and I press OK. So this window will open where all the parameters are there regarding anchor bolt. So if if any parameters is wrong, SDS will not allow me to go further and add this anchor rod. So this will save a lot of field and shop calls. Here you have type of rods, your grades, your finish, and what all washers and plates you want above and below the base plate. So as I press OK, all the anchor rods you can see are now added here. So now I don't want to add another group. Now simply I'll go to another elevation, that is 112-0. Okay, and what I will do here, I will import my next set of array shop drawings. Close. So I will start adding my beams. W14 by 43. Okay. So I will just simply, as I add the beam, you can see automatically the connections are being generated, which is the USP of SDS2. So I will quickly add on the beams. this beam is W 18 by 35. The other beams. Now you can see all the beams are added. So I just solid up like this. Now I talk about the connection design. So if you see this connection and if I double click this and I change the connection from clip angle to clip angle. So here you can see the connection has the SDS is auto calculated that for a clip angle the connection can withstand 95 kips of load while the shear tab can withstand a 49 kips of load. Okay, so as I press OK, so it will prompt me and just say no. So now this side connection is changed to clip angle. Okay, now we'll do the same thing here. Okay, so this is 3-bolted connection. If I go here and on the right hand side, if I instead of changing the connection, I change the load. So I change the load to 60 kips. Okay, and I press OK. So now you can see it has changed the number of bolts. So and SDS also gives a connection calculation report. So if I open this, if I press save, so SDS will generate a connection calculation report for this. It will take some time to open. Yeah. So now you can see SDS has generated a connection calculation report where it has all the parameters given, all the schedule of minimum, what all parameters it has considered, what is the beam elevation height, what is the tension and other things. Okay. Also, one good thing is SDS will also map the AISC or whatever connection calculation reference number for parameter that it has considered like shear yield, plate and all those parameters. Okay. So and anything it any comment SDS will mark like connection is okay or strength is not proper, anything like that. This calculation you can submit to your fabricator also. Okay, so I just cancel this. Okay, now since there is not much time, I'll simply just show you how to detail a drawing. So I'll just simply go here and I'll just detail a member. The beam number is B_28. So since in SDS you feed a lot of data before starting the job, SDS has gives you a drawing in a very clean up way. Okay, so let it complete the detailing. So now detailing is complete. I close this and I go to a drafting module. So my drawing which was detailed is B_28. You can see this is how the detailing comes in SDS. So almost 90% of the beam is already detailed. If you see all the other details, I've already cleaned up those drawings and I have not done anything. I just simply took out these drawings from SDS. Similarly, there are some column drawings also. You can see this is how the column comes where your north face is there, all the cut operations are there, all the elevations marked, all the section view SDS only taken, this bottom base plate views. Okay, then top view is there already. Okay, so you now bevel cut on the top, bevel cut is required, SDS has given it directly, this profile size and everything SDS gives. So it helps you to expedite your work. Okay, and later you can just simply export all the drawings and I have already have these drawings here. So these kind of drawings you can export and bill of material and everything will be here which you can submit later, submit to the fabricator.